Hi there, this is Penelope, and this is questions 1 and 2 for MG5004, the 2016 exam. So, first question, you are drawing a graph where it's expressed parametrically. The solution there is to draw yourself a table with the three variables, and it suggests that you go from -4 to 4. So let's do that. And then we have to work out the x value. So if x is -4, if t is -4, then x is t cubed. So that would be -64. If x is -3, then if t is -3, then x is -27. And the same all the way across. Then you have to work out the y values, and y is equal to t squared. So when t is -4, it would be 16. And then it's the x and the y variables that you need to sketch. So when you plot these with x and y, and you're going to have to go fairly small, say 5, maybe make that 10, 20, 30, etc., etc. And what you get, just ignoring my axes scale for the moment, you're going to get a curve that looks like that. The second part of the question asks you to solve cos theta over 2 minus 20 degrees equals -0.5516, and it tells you that x is between 0 and 360. My preference is that you say let z equal something. In this case, theta over 2 minus 20, so cos z equals -0.5516, and you know that should be in quadrants 2 and 3. So z equals inverse cos of -0.5516. That gives you that z is equal to 123.477 or 236,523 from your calculators. Then remembering that actually you weren't asked to find z, you were asked to find theta, so theta is equal to z plus 20 times 2. So that allows us to find theta as being, use your calculators, 286.954 or 513.046. Now that one's clearly out of range, so we just have one answer there, 286.94. Now the third part of that question asks you to rewrite y equals cos 2t minus 2 sine 2t. You need to recognize that a is equal to -2 and b is equal to 1. That allows you to find that alpha is tan inverse of b over a, which is 1 over -2, and that r is equal to the square root of -2 squared, which is 4, plus 1, so it equals √5. So we can rewrite that as y equals √5 times sine 2t plus 153.435. Now the second part of that asks you to solve where that is equal to 1. So we've got to say then that √5 sine 2t plus 153.435 equals 1. Divide both sides by root 5. Make a substitution as you did in the previous part of the question, and you will get that t is equal to, trite solution would be 0, and the next solution would be 106, and the next solution would be pi, or 180 actually. For question 2, let's start with A. Solve 4 3x minus 2 equals 26x plus 1. This is a log question. It doesn't matter whether you take natural logs or positive logs of each side, but 3x minus 2 natural log 4 equals x plus 1 natural log 26. Now multiply out that. On both sides. And then put all the x's on one side. And the numbers on the other. Factorize the left. And then divide both sides by the bracket. Now, whatever that equals, I don't know. You just work it out with your calculator. Part B says rearrange P over Q equals the square root of A plus 2B over A minus 2B. It's a kind of similar sort of situation. You've got to do lots of multiplying out and cross multiplying. First up, you would square the top and square the bottom to get rid of the square root sign. Now you would cross multiply. Get rid of your brackets. Collect up the like terms, so you'd have p squared a minus q squared a equals q squared 2b plus 2p squared b. You're looking for b. b is equal to p squared a minus q squared a over 2q squared minus, plus 2p squared. For the next part, where we've got to resolve it into partial fractions, we have 9 minus 4x over 3x squared minus x minus 2. We can factorise the bottom so that we've got 3x plus 2, x minus 1, and that enables us to write that 9 minus 4x equals over 3x plus 2, x minus 1 equals a over 3x plus 2 plus b over x minus 1. Now we can just cross multiply and then multiply top and bottom by the two brackets to leave us with 9 minus 4x equals a times x minus 1 plus b times 3x plus 2. And you remember you start off by saying, well, if x is equal to 1, then 9 minus 4x would be 5 is equal to, that first bracket goes, and we're left with 3 times 1 plus 2 is 5, 5b, so b equals 1. If x was equal to negative 2/3, then 9 minus 5x would become 35 over 3, and the second bracket would go and we'd be left with, in the first bracket, negative 5 over 3a rearranging that gives us that a is equal to -7. So our decomposition becomes -7 over 3x plus 2 plus 1 over x minus 1. The next part of the question, solve the absolute value of 2x minus 1 is less than 1. Remember that if 2x minus 1 is positive, then the absolute value of 2x minus 1 equals 2x minus 1. And if 2x minus 1 is negative, then the absolute value of 2x minus 1 is equal to -2x minus 1. And then it's a matter of solving each of those being less than 1. So for case 1, 2x minus 1 would be less than 1. That would give us that x was less than 1 in case 2. If we're solving -2x minus 1 is less than 1, then that gives us that x is greater than 0. So those are our two solutions. 0 is less than x, which is less than 1. The last part, y equals 2x plus 4 over x minus 3, and you're asked to find the inverse. So first up we need to find what x equals and then swap the variables. And that's because we're reflecting in the line y equals x. So y times x minus 3 equals 2x plus 4. Get rid of the brackets. And then swap them around and factorize. And give yourself that x is equal 4 plus 3y over y minus 2. Now doing the second step, which is swapping the variables. So the inverse is going to be y equals 4 plus 3x over x minus 2, provided x is not equal to 2.